So what happens when you're in this type is context situation and you don't want to be, right? We've got to use the custom error types, but we want to maintain that level of decoupling. This is where we're going to have to focus from type as context to type as behavior, right? Or behavior as context, to be honest with you. Our context is going to move from type to the behavior, right? Not what is, but what does. Let's take a look at some code that will teach us this. So I've pulled a little code out again out of some kind of like normal code we would be using if we were going to maybe read something over the network. And what I have is this client that has a reader. The reader is an interface. There'll be some concrete value stored inside of there that knows how to read. And in this case, we're going to be reading a string maybe over the network. Now, we're going to be blocking here until one of two things happen. Either we read that string up into that carriage return line feed, or we get an error. So when the read string call returns, we check to see, is there a concrete value stored inside of ERR? And if there is, we know we have an error. Now, what we're doing right now is still type as context, right? What we're saying is, let's perform the type assertion on the switch, and if the concrete value stored inside of ERR is a pointer to the op error, let's execute that case. If it's the address of an address error, let's do that case. The address of a DNS config, you're getting it, because the net package has lots of different error types. I mean, networking is complex. But the op error is the most common error type that we'll use in Go. In fact, I want to bring up the op error type so you can see the implementation of it from the standard library. So I'm going to do that golang space OS search. The OS package is going to come up here. And what I want to do is find that op error type. Let's see if we can find it here. Type op error. Let's see, op error. You can see here what we're doing. So we're going to look for that op error type in the net. Oh, no wonder. I'm in the OS package. You got to love that. Let's try it again. Net golang. There we are. Going to move into the net package, no problem. Going to do a quick search for type.op error. There it is. And I'm actually going to jump inside the code. Now, I don't know why they love that orange looking color, but we're on line 425. So let's just move over to 425 real quick. No problem. There we are. And there's that op error type that I want to share with you right there on line 425. And notice that the op error type is an exported type. All of the fields are exported, so the language team is allowing you to fully inspect at the concrete level this error. Again, the whole point right now is we want to try not to do that. And here's the implementation of the error interface. Let's make that a little bit larger so you can see it. There it is. You can see how complex the message is going to be for a networking error. And that op error type, again, is really one of the most common error types you're going to get back. Also notice we're using those pointer semantics again on the implementation. Now, you can see here that that is definitely implementing the error interface. But notice what we're doing here on this in this switch case. In every case, what we care about is calling a method called temporary. Remember, errors are just values. They could be anything you need them to be. And that just isn't state, it's also behavior. And it's really nice when there is behavior tied to these error values, like temporary. And you're told when there's a networking error, call that temporary method. If it's temporary, then you can keep going. And if it's not temporary, then you have a nasty integrity issue. Maybe that socket connection died. Maybe your listener died. Something bad. Let's go and take a look at the implementation of temporary here, at least for op error. And there it is right there. Let's just scroll right into 502 right there and take a look at it. So there's the implementation of the temporary method. And you can see here that there is a lot of type assertions going on. And thank goodness the language team wrote this, because there's no way I personally would have figured out how something is temporary or not without this type of support. You can even see we've got some special comments. This code, I think, is new even from as late maybe as 1.8. This was some new error handling. Again, what was nice about the method was they were able to make some implementation changes to make this more accurate. And it didn't create a cascading effect throughout the code base. That's what we're looking for. So you can see here that this temporary method returning true or false is really a great way of providing some extra support to the callers. But in every single case here, what is it we're trying to do? We're just trying to validate whether or not the error was temporary. That's all I really care about. And it's that behavior that I care about, not necessarily the fact that the error is of one particular concrete type or another. What I find fascinating here is Go, at least the net package did implement an interface called temporary. There it is on line 498. But what do you notice about the temporary interface? You should notice pretty quickly that it's an unexported type. And you might say, well, why is this interface unexported? Again, do we as users of the net package have to implement the temporary interface? The answer is no. This is being only inside the net package. Are there multiple implementations of temporary? So here's an interface that there's multiple implementations, but it's an internal, right, use. It's not external. But it would have been nice if it was external, because we could have used it to do our own type assertion. Think about it. When we talk about behavior as context, what we're saying is, I don't care if the error is op or add or DNS. What I care about is if the error value has a temporary method, that's what I want to work with. So look at what we can do. I could get rid of this code using type as context. I can go ahead and define my own interface. I could call it temporary. Yeah, I could also call it the bill interface. There it is. I'm defining my own bill interface. And isn't it true that op error, address error, DNS configure, isn't it true all of those error types in the net package that have a temporary method now implement the bill interface? Yeah, absolutely, it's true. Which now means that I can take all three of those behaviors, all three, and bring it into one case statement on line 73. Now what I can say is, hey, the concrete value stored inside of error, if it also implements the bill interface, then we're done, and we're going to call temporary on it. And now we've got that behavior as context. And that also means that we don't have that breaking change anymore. If we add new concrete types, if we make changes to those concrete types, this code is stable because it's not based on what the concrete error value is, it's based on what it can do. And now we can handle a bunch of cases in one place because of behavior. This is what we're going after all the time. I want to maintain this idea, especially around error handling, that if we can focus in a decoupled state and it's adding value, it's going to maintain our code base and keep it stable longer. So I love this idea of behavior as context.